So this is paper 41, May, June 2021. We have discussed question number 3 till B part 2, B part 1, and we are going to start part 2. Draw a fully labeled diagram of the apparatus that can be used to measure the cell potential of a cell composed of this and this electrode, include all necessary reactants. So, you know, in this diagram, you are not supposed to represent She. She bole to simple hydrogen electrode, because in this they are going to basically find out the unknown electrode potential. Okay, and obviously these are two half cells, so you need to combine them together, and then you would be getting the final cell potential. So I'm supposed to draw this. This is your first half cell. This is your second half cell. This is your salt bridge. Okay, this is your salt bridge, and then this is your electrode. This is voltmeter. Okay, in this beaker you have solution, and in this beaker you have another solution. Simple. So can you tell me what is an electrode? Like, made of what? Made of copper or made of iron? What do you think?
Platinum.
Sorry, your voice is not clear.
Platinum.
Platinum. साहिल क्या कहते हो?
Platinum and copper.
No. साहिल क्या कहते हो? What is the material of an electrode?
Graphite.
In this, they have told you that copper is your electrode, but in this diagram, in this, basically, you have two ions, mixture of two solutions, iron 2 and iron 3. Whenever you have mixture of two solutions, means that you have Fe2 plus and Fe3 plus, aqueous.
There's no
Aqueous.
platinum, right?
Exactly. So whenever you have this condition, so you will say that the electrode is made of platinum. Always remember, always. Not only for this, any other ions you have, but a mixture of two solutions, remember. So, and this is made of copper, which is dipped in copper 2 plus solution. This is your voltmeter. This is your salt bridge. This is your salt bridge. Or, okay. So the reaction between thiosulfate S2O82 minus and iodide is catalyzed by adding a few drops of iron 3 plus, which is homogeneous catalyst. If you remember, we discussed kinetics. In that chapter, I told you the types of catalyst, homogeneous and heterogeneous. Use equations to show the catalytic role of iron 3. You need to memorize this. You need to memorize these two equations. If you remember, I told you these two equations. So first of all, your iodide is going to react with your iodide is going to react with iron 3 plus. Always iodide would be converting into iodine and iron 3 would be converting into iron 2 plus. Means that iron is reduced and iodide is oxidized. Okay, I need to balance this equation, so I need to write 2 and 2 over here. Okay, and then S2O8 2 minus gonna react with again Fe2 plus that is produced in the first equation. Since this is a catalyst, so what is the definition of catalyst? It is regenerated in the end of reaction. So it would basically, you can see this. This is how the catalyst works. Fe3 plus can oxidize iodide, whereas iron hexacyanide cannot oxidize iodide. Use E naught values to explain these observations. They are saying Fe3 plus can oxidize I minus, okay, but FeCN6 cannot oxidize I minus. Why? Means that Fe3 plus is a stronger oxidizing agent and FeCN6 3 minus is a weaker oxidizing agent. That's the reason it's not able to oxidize iodide into I2. So so you have to use the E naught values. You will be provided a data booklet. Sorry, obviously, like onwards, he would be giving you the necessary data, and for sure he would be giving you the necessary data. Uh, so I'm saying that I'm providing you the E naught values. You can see that I2 slash I minus is this. Okay, and okay, and uh, ये आपके पास E naught values हैं. You can think, okay, why FeCN6 is not able to oxidize this iodide like I minus. Since you can see that FeCN6 has a lower E naught value, like the less positive E naught value as compared to iron 3 plus. You know, when we discuss theoretical portion of the same chapter, that is electrochemistry, so we always say that more positive E naught value means that it is stronger oxidizing agent. Okay, and the lower E positive value represents that this is a weaker oxidizing agent. So I would mention this is of 2 marks. I would mention that, okay, uh and also, they are saying, uh, we always calculate the E value, like the E cell value, like the total value from the two half cells. Okay, and if the overall answer is negative, okay, if the overall answer is negative, so we say that the reaction is not possible. And if the answer is positive, and it would be very good if it would be more than more than 0.4, more than 0.4. So we can say that the reaction is possible and it can oxidize, it can oxidize. So what you are supposed to do, you are supposed to calculate the overall value means that I want to do a chemical reaction of this and this. So what am I supposed to do? The E naught value for iodine to iodide is 0.54 and FeCN6 3 minus 2 4 minus is 0.36. So you can solve this by calculating E naught of cell, that is equal to 0.36 minus 0.77. Can you tell me an answer? Can you tell me an answer? Yes. Hmm? Yes.
Sir, it's negative 0.41.
0 point. It's negative 0.41. 41 means that K, the reaction is not possible because the E naught value is negative ultimately. Okay. And the other thing you can write over here, K, you can say that K, this is more positive than this. If this is more positive than this, so how can I say that FeCN6 is going to oxidize this? You know, it's the same as कि जब आप देखते थे कि KCl is going to react with Br2. KCl is going to react with Br2 since bromine is less reactive than chlorine. Since the bromine is less reactive than chlorine, so how it's going to displace just like that, how it's going to displace since this is less reactive than chlorine. So same goes over here. You are going to react this with this, and if I'm going to have a comparison between the values, so I can see that this is more reactive than this since its value is more positive. It's stronger and it's weaker. So how can I say that it's going to oxidize this iodine? So you can also write that uh, since the I2, since I2 slash I minus is more positive than FeCN6 raised to the power 3 minus. So that's the reason it would not oxidize this. It would not oxidize this. Okay. So therefore, whenever you see these type of questions that it's not going to oxidize this value, this species, so means that ultimately the first species is having the more positive value and another species is having a less positive E naught value. It would remain the same for all the questions. Remember, it's the concept. It's the concept. So I told you that a resemble equation, like from the halogens, if the halogen is more reactive, so it can displace the previous one, and if your halogen is less reactive, so how can I expect that it's going to substitute the previous halogen? It's not possible. To do a chemical reaction, the coming one should be stronger than the previous one so that it can displace and it can react. Same goes over here. Same goes over. That's why we are going to look at these values. That's the reason. So this is of 2 marks. The first mark you would be getting by writing the E naught values from the data booklet. Okay. And the next thing is that you are going to like explain why they are not going to react. So obviously I can say that it is more positive than this. तो आराम सी आसान सी बात है, कोई मसला ही नहीं है इसमें. Suggest why this reaction is slow without the Fe3 plus catalyst. Since you know that negative, negative, negative all have negative charge, all have negative charge. So kinetically, it's not possible, how can they would collide with each other since they have a negative charge? How can they react with each other? They would collide and they would bounce back. They would not react ultimately because they both have a negative charge. Same charges repel each other, na? तो इसलिए if you are not going to add any catalyst in this, so the reaction would be very slow. The reaction would be very slow, remember. But the reaction is possible. If you remember, in electrochemistry, I used to tell that whenever you are going to decide to do a chemical, whenever you are going to like determine whether a chemical reaction would take place or not, so we used to solve the two E naught values. Just I told you that if you are getting the positive value, so I can say the reaction is possible, otherwise not. So if you can take the value from the data booklet, so you will see interestingly that the E naught value would be positive for this reaction. That's why I'm saying that the reaction is possible. But why this is very slow? Since the two species have a negative charge, so they are going to repel each other. That's the reason the reaction is very slow. So this is of 1 mark. This is of 1 mark. So I can say that S2O2 minus and tartarate ion tartarate tartarate ion have a negative charge, so they will repel each other. They will repel each other. Use the overall equation to deduce the half equation for the oxidation of tartarate ions. This two carbon dioxide and methanoate ions. Oxidation to reduce the half equation. Tartarate, first of all, carbon dioxide you are supposed to write, and you are supposed to write HCO3, HCO2 minus, HCO2 minus. They have mentioned, okay, or you can say that K. Uh, Use the overall equation to deduce the half equation for the use the overall equation. This is your overall equation. Okay, this is your overall equation to deduce the half equation for the oxidation of tartarate ions. So I'm going to remove this and this. Okay, so I'm gonna write this or this. Okay, and 2HCO2 minus. I'm going to copy this 100%, or obviously I need to balance the charge as well. So what do you think कि मुझे यहाँ पर कौन सा charge लिखना चाहिए? Here or here? Can you tell me the charge on the reactant side and the product side? It's 2 minus. It's 0. It's minus 2 and it's plus 6. So means that plus 4. Plus 4. So I'm supposed to add 6 electrons. You know why? Plus 4 and minus 6 would give you minus 2, and this is also minus. So the charge is balanced. This is your half equation. In this way, you
Sir,
can balance the equation. Yes?
can you repeat this part again? I don't
Yes.
understand.
Basically, this is your overall equation. Overall means that it's the sum of two half cells. Sorry, it's the sum of two equations. It's the sum of two equations. So they are saying use the overall equation to deduce the half equation for the oxidation of tartarate. And this is your tartarate ion. It's gonna give you this, this, and this. This is your first half equation, and this is your second half equation. I'm not supposed to write the second half equation. With the help of overall equation, I'm going to write the first half equation. So then after writing this, I would be including this, 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 and this. So then I need to balance the charge. So you can see here, this is -2, this is 0. There is no charge on water. So on the product side, you must have -2 charge. But how? Right now you have -2 and +6. So the overall charge is +4. Which number I'm gonna add in this to make it -2? Ultimately, I need to write -6. So that's why I have written +6 electrons so that I can get the -2 charge. That's the reason. Okay, Tala, are you getting me?
Yes, sir.
Organic chemistry. Complete the following table to show the structure of the organic products formed when tartaric acid reacts separately with each reagent. Identify each type of reaction. Identify each type of reaction. So this is your reducing agent. This is your reducing agent. So you have carboxylic acid. So carboxylic acid can be reduced into primary alcohol. Carboxylic acid can be oxidized into primary alcohol because you have used excess reducing agent. Since the type of reaction is reduction, so let me write this. Okay, you would be getting OH, that would be the same, and that would be your, I can say, primary alcohol. Okay, that's it. This is primary alcohol, right? Uh, Excess ethanol chloride. Ethanol chloride. So what it would do with this, with your provided, with the given reactant, that is tartaric acid. So let me copy this tartaric acid. It's your tartaric acid. In this you have two carboxylic. This is your OH and then OH, or you have carboxylic acid and it would be reacting with your CH3C double bond OCl. Okay, or uh, they would be reacting with, they have mentioned that this is in excess. This is in excess. You know what it would do? It would react with your alcohol. It would react with your alcohol. Since this is a derivative of carboxylic acid, this is very important point I'm telling right now. This is a derivative of carboxylic acid, so it's not going to react with carboxylic wala part. Okay, it only reacts with alcoholic part. So as a result of this, you be getting this, the same thing, carboxylic acid portion would remain the same, that is this, and your alcohol would be converting into OCOCH3 and OCOCH3, and HCl would be removed. But they are saying that you are supposed to only mention the organic product. That's why I'm going to mention only organic product, that is this. Since you are going to remove a small molecule, when you are going to add the two molecules, so the small molecule is removed, that is HCl. Sometime it may be H2O. So that's why I can say that the reaction is condensation. Reaction is condensation. When there is a loss of a small molecule, so I can say the type of reaction is condensation. Okay. Tartaric acid reacts with the amine, 1-phenyl ethyl amine, that is this, to form an ionic salt
Draw the structure of the salt formed in this reaction. Include the charges on the ions. Let me write down first the structure of one phenyl ethyl amine. Since this is your phenyl ring, since this is your phenyl ka ring, okay, or this is the double bond in the benzene ring, okay, and I can say that this is your carbon and this is your CH3 and NH2 and this is your hydrogen. Okay, this is the structure of one phenyl and ethyl amine. Okay, and it's going to react with tartaric acid. The tartaric acid is this. So tartaric acid has one, two, three, four carbon atoms. Okay, one, two, three, four carbon atoms, and on the corners you have carboxylic acid. That is this, and this is your OH. This is your OH. Okay, when they would be reacting together, ultimately this carboxylic acid would be attacking on this phenyl amine ammonium, amine, okay, amine is a base, amine is a base. So they are saying that draw the structure of the salt form in this reaction, include the charges on the ion. Since you have carboxylic acid, and this is your basic part, so acid base reaction would happen because they are saying that ionic salt is going to be formed. So what am I supposed to do? I can say that the carboxylic acid would donate its proton and the amine wala part is going to accept proton. So I'm going to copy paste this. Again, all the things would remain the same, but what I would do, you can see this. Okay, negative charge, or it would be NH3 having a positive charge. Simple. These are called ions. That's it. Samples of copper H2O6 are reacted separately with an excess of aqueous sodium hydroxide or with an excess of aqueous ammonia. Give the following information about these reactions. Reaction 1 में कह रहा है कि with excess ammonia, with excess sodium hydroxide. Color and state of copper containing species. So I told you whenever a copper complex is going to react with NaOH in excess, so in the end of reaction, you will see the blue ppt. You need to memorize these all the things. If you know all equations, you can write it down easily. Otherwise, it would be very difficult for you. You need to memorize some equations as well from the transition elements. तो कॉपर H2O6 एंड ये पूरा रट्टा है, आपको पता है, तो इसलिए जस्ट चिल. If you have memorized, so that's it. And if you haven't, so just look at this and you need to memorize it. So this would be formed. Water is removed. It's called a ligand substitution reaction. So this is blue ppt. Okay. With excess of ammonia, I remember, the deep blue solution has been formed. The deep blue solution has been formed. And what's an ionic equation? So you will say that copper H2O6 2 plus reacts with 4 ammonia. Okay. So As a result, you will see copper, and then you will see ammonia, four molecules of ammonia, and then H2O2, then the charge is 2 plus. Four water molecule have been removed. So this is going to give you a deep blue solution with excess ammonia. With excess ammonia, remember. So these things you have to memorize. I'm not going to do an experiment in front of you like this is going to be displaced and four molecules and we can see vapors on the surface of beaker on the walls of the test tube. So obviously means that the water is being evaporated. No man, you need to memorize each and everything. Again and again I am saying because these things are related to your knowledge. It's not a concept. It's a recta equation. If you can see the notes, ditto 110% all the equations are written on the same in the same manner. Nothing is changed. They have asked, I have just copied pasted. That's it. Copper 1 oxide is added to hot dilute sulfuric acid. A blue solution X and a red brown solid Y form. Copper 1 oxide is this. Copper 1 oxide is this. Okay. Cuprous oxide is added to hot H2SO4. H2SO4. A blue solution is X and a red brown solid Y forms. Blue solution is copper sulfate. बच्चे बच्चे को पता है. And brown solid is copper. What's the type of reaction? What's the type of reaction? You have copper sulfate and you have copper. So copper 1 is changing into copper 2 and 0. 1 to 2 is oxidation and 1 to 0 is reduction. The reaction in which the same species is oxidized and reduced. Can you tell me what's the type of reaction?
Disproportionation.
Simple, easy. Disproportionation reaction. Okay. Okay. Hi, hi. What measurements could be used to follow the rate of this reaction from the given information? Yes. क्या कहते हो? Easy है यार. I'm going to measure the rate of reaction. Okay. Yes. Common sense. Common sense. Hmm?
Measure volume of
हाँ ना और क्या measure the
gas.
volume of oxygen simple यार measure the volume of oxygen simple per unit time always so can measure per unit time. The reaction is first order. Okay. First order means that the first half life is equal to the second half life. Okay, I told you. Explain the term half life of a reaction. So you know what is half life? The time taken, the time taken, time taken for the concentration of a reactant of a reactant to become half. to become half. Determine the half-life of this reaction. Show your working on the show your working on the graph. Okay. So can you tell me the half-life? Initial concentration is 0.25. Okay. So the half of 0.25 would be equal to what? Huh? क्या कहते हो? Yes. Half of 0.25. Can you divide it by 2? Yes. बताओ ना यार, इतना टाइम क्यों लगाते हो?
0.125.
0.125. 0.125. Okay. So 0.12 means that, can you tell me where the 0.112 would lie on the graph? So what's the difference between these five boxes? It's 0 and 0, 0.05. So each box would be of what? 0.01, 0.02, 0.03, 0.04, 0.05. Okay. Then 0.1, then 0.1112, and 125 would be in between this. Am I right? Yes or no?
Yes, sir.
So, oh, okay. Can you tell me the time? It's
150.
exactly in between. Exactly. This is 150 seconds. So, okay. Suggest the effect on the half-life of this reaction if the initial concentration of N2O5 is halved. Initial concentration अगर half होती आपकी, means initial concentration would be this. So, what would be the half-life? Remember, the half-life would not change. The difference would be the same. The difference would be the same. No change. This is concept. It's a pure concept. It's a pure concept. You can check this. You can check this. You can check this. So can you half 0.12? Can you half 0.12? 125. Can you tell me an answer?
0.0625.
So 0.05, 0.06, it would be around that. Would be around that. So you will see the difference would be the same. The difference is same. So that's why I'm saying the half-life would not change. That's why no change in half-life. Use the graph in 5b to determine the rate of reaction at 200 seconds. Show you're working. $200. Yes. What do you think? 200 seconds. Huh? You can take a tangent. You can take a tangent. Okay. So the rate is the concentration per unit time, per unit time, per unit time. Yes, what's the answer? Hmm? Hmm. At 200 seconds. Determine the rate of reaction at 200 seconds. What's the answer?
5 multiplied by 10 to the power negative 4.
5 multiplied by 10 to the power negative 4. क्या डिवाइड किया साहिल? How did you get?
Concentration divided by time.
Which concentration did you take? Yes.
I took 0.1.
0.1. नहीं. 0.1. Why? क्या कर रहे हो? Tala, what did you get your answer? How? Can you tell me why this is so? Yes?
I don't know, sir.
Oh, okay. This is your concentration. This is your time. So I would be dividing 0.2, 0.2 divided by 400. I would be getting this. Okay. This is your rate. आंसर सही बताया है लेकिन नहीं पता. भाई ऐसे होगा ना यार. Concentration
5
divided by
times 10
time.
power negative 4, sir.
Exactly. 5, 10 times to the power negative 4. This is negative 4. Stylish 4. Mole per dm cube per second. Always. Mole per dm cube per second. It's the rate. It's the rate. Okay. You know the rate. You know the concentration. Can you tell me K? Can you tell me K? Hmm? Rate is this. Hmm? 0.2 थी ना ये. हाँ 2 थी. Can you tell me K? जल्दी से. Yes. जल्दी.
Sir, I got 2.5 times 10 power negative 3.
Sorry. 2 point.
2.5 times 10 power negative 3.
2.5. Negative 3. Okay. The rate equation is shown. Use your answer to C part 1. To C part 1. Okay. Are you getting the same answer? Can you tell me?
Which answer, sir?
Sorry? Yes, this answer.
Yes, sir. 0.2 divided by 400 is 5 times 10 power negative 4.
Means it's correct?
Yes, sir.
Okay. And concentration is N2O5. N2O5 is, they have mentioned the concentration. Or okay. Determine the rate of reaction at 200 seconds. Okay. Can you divide it 0.1 over 200? Can you divide it 0.1 over 200?
It's the
The
same
answer
answer,
is
sir.
same.
The answer is same.
Yes, sir.
Okay, good. That's good. So I'm taking the concentration, that is, I'm taking the concentration 0.1, not 0.2, because they're asking at 200 seconds. So what's the answer now you're getting? Yes.
5 times 10 power negative 3.
So, and what would be the unit? You can solve your unit. So that would be rate is equal to K times concentration. Rate is mole per dm cube per second over mole per dm cube means that the unit would be per second. The unit would be per second. Okay.
Okay, sir.
Yes. Yes. Suggest a possible two-step mechanism for this reaction. Two-step. I told you it's a common sense. You can solve it very easily. And obviously, you need to do any intermediate. You need to write any intermediate so that you can cancel. क्या कहते हो? ओए, ओए। Since this is your intermediate, so in the second equation, it must be included so that it can be cancelled easily. I need one more N2O. I need one more N2O. And I need one N2O5. Okay. So cancel, cancel. So ultimately, you would be getting 2NO, 2N2O. You would be getting O3. You would be getting N2O5. You would be getting O2. So these are your two-step equations. That's it. Okay. Oh my God. Still the paper is remaining. Okay. So we will do this, inshallah. Question 6 is related to ionic equilibria, and this is organic chemistry again, polymerization or Abey bhai, oh my god. Okay, we will complete the paper inshallah in the next class. Okay, Allah Hafiz.